Okay, I want to go over the 1.4 quick check. So first it says put 7 dots for someone who is precise but not very accurate. Well, if they're accurate, we expect them to be on the bullseye, so we're not going to put it on the bullseye, but they are precise, so 3, 4, 5, 6, 7. Okay, so we're going to put them at precise, which means they're very close together, okay, very repeatable, but not on the bullseye. Now you can put it anywhere you want to as long as not on the bullseye, and they should be pretty tightly spaced. Okay, second thing is we want to go, we want to go up to the next question here. So this says, okay, here we have 4 students, and they're measuring the same object. So how are we going to show their data? So what we're going to do is we're going to 3 steps. We're going to take the average, we're going to find the deviations, and we're going to get the average of the deviations. So the average is here. I'm going to add these together. And when I average them together, when I add them together, I get 60.80. And to get my average, I need to divide by 4. And I get 15.2. So my average value is 15.2, and that's going to go right here. Now I want to see how far each one of these deviate. So 15.2, 15.25 minus 15.2, this would be 0.05 is my deviation. 20 and 17.03, my deviation. 0.05 and 0.03. And again, I don't care whether it's too high or too small, I just want to care about how far off they are. Now I can kind of do these, I'm going to add these up, 5, 5, 3, and 3, so that's like 16, so 0.16. But again, I need to divide by 4. So these are my deviations. And I want to average my deviations, and it comes out to be 0.04. So put that here, and that's my final answer. Okay, 15.20 plus or minus 0.04. My average and my average deviation. Okay, next one, percent error. Knowing that the actual density is 2.6998 grams per cubic centimeter, which period is most accurate? Okay, so I'm going to say whichever one is closest to 2.6998. And I can see that the 2.70, okay, that's the one that's closest to 2, because this rounds off to 2.70. So period 3 would be the most accurate. Now calculate the percent error for period 5. Okay, this is just a formula, and we have to memorize this. So it's going to be the actual minus the, we're doing number 5. The actual is 2.6998 minus 2.60. So we're going to take the absolute value of that. So you really want to see how far are we off, divided by what it's supposed to be, and take that whole answer and multiply by 100, and that's going to make it a percent. So I'll take a second and calculate. And when I do that, I get a value of 3.69. 3.69. I was going to call that 3.7%. So again, all I had to do was go back and subtract this value and this value. Okay, see how far I'm off. Divide by the true value, and then multiply that answer times 100. That's percent error. Now the next question up here says, well, which period is most precise? Justify your answer. Well, here we have these plus or minus values, and these plus or minus values are pretty important. And what they're saying is that if we were to take measurements, for the same thing, how close would those measurements come to each other? So this one here, the red ones, this would be a certain plus or minus value, okay? But for my green ones, that would be a smaller plus or minus value. And the blue ones would be a larger plus or minus value, because there's more spread. So the most precise is whichever one has the smallest plus or minus value. So of these periods, who's the most precise? That one is the 0.1. So period 2 is the most precise. Okay, and the reason is, okay, the values have the smallest variation, and that is shown by the plus or minus value. And that's the quick check.